Now, in the body plan that you have drawn, I have talked so far about the position of the stations along the length, but there is another term which is more important than these stations, or equally important, is the position of what is called the frames, because ultimately the ship is going to be built. So, here even if you mark the stations, say this is your forward perpendicular and then the after perpendicular is somewhere here, and this is your midship section, you mark the position of the frames. Either they are marked or the extent of these frames are indicated from the forward perpendicular, say normally by means of frame spacings. So, here in the lines drawing you might find that this distance say will be say 760 millimeter frames spacing. Then from here say the position here will be another set of frame spacings. So, these are clearly marked in your lines drawing. All right till the end you have the frame spacing. Normally at the forward end you will find the frame spacings are more near to one another or closely spaced. The forward and the aft region you will find the frame spacings to be closely spaced, and frame spacing normally you have this they are spaced 500 millimeters, say to it can be as large as 1 meter. Normally around the ships that have come across 750 to 800, that type of frame spacing. So, frame locations are important in the shear plan or the profile. Of course, you do not show the frame spacing in the body plan or the half-breadth plan, it is not necessary, but in the profile it is invariably marked. So, in any lines drawing you will find, besides your station markings, that is your 0, half, etc., the frames are marked, that is by small vertical lines on the baseline like this. So, they show the position of the frames, and the spacings are clearly indicated from the forward perpendicular. Now, these frames actually they pertain to the frame spacing. Actually they have to follow the internal structural arrangement. Since they define the structure or define the frames, so they have to follow the internal structural arrangement, especially related to frames and longitudinals. Now, what happens at the stern, you will find the shape of the ship is very much curved like this. Say this is your deck line, stern is very much curved. Now, here it is difficult to have a frame which is vertical like this. Why? Because you cannot weld or join properly, especially in this region. Welding is going to be very difficult. You cannot put the welding rod, there will be difficulty in closing this stern structure. So, what you do normally, what is done, this arrangement, the frames are not made vertical to the center line, but they are made normal to the ship's shell plating or ship's side like this. You can see this arrangement at the stern of the ship. you go near the deck or in the steering gear compartment, you will find that these frames are made in a radial and distribution along the stern, and these frames are called cant frames or cant frames. And very rarely you will find at the bottom of the ship, where also there will be difficulty in welding, etc., and due to other load distribution, you may find frames which are in a slant to the baseline. They are normal to the center plane, but they are not vertical, but they are at an angle with the baseline. So these frames in ships, normally they may not be vertical, but they can also be slant. But especially this is of course very rare, but you may, if you look into certain ships, you will find that this slanted frame also is existing. So that is because of the shape. In the forward region and in the aft region near the stern also, you will not find enough space for welding and other structural details. But at the same time, you have to maintain adequate rigidity to the structure, give adequate rigidity, isn't it? If you don't give adequate rigidity, then there will be distortion in the shell plating and there will be likely rupture. So in order to give sufficient rigidity, you simply orient the frames according to the direction of the maximum stress, where the maximum stress will come. So those arrangements in the shipyard itself, or the naval architect who is making the drawing, he has to keep this in mind. Of course, the lines will not be very much altered, that is, the molded lines will be the same, but your framing plan has to show this clearly. So normally after the lines are drawn, for structural arrangement, you make what is called the frame. This is called framing plan. So here you draw molded sections. At molded sections at particular frame positions. Frame positions in the profile. So coming back to this drawing, at this particular position on the body plan, you make another frame plan, which is nothing but another body plan, and instead of marking the station from 0, you write this is frame number 10. This is the molded shape of frame number 10. Then you have, say, frame number, say at the aft you will have frame number 20. So this is called the framing plan. Like this you can go on, but of course it is very difficult to draw all the frames. So normally what is done in the midship, you will find a lot of similarity, especially in the parallel middle body. The molded form is going to be the same, so you can just draw one frame and say that this frame is from 10 to 20. You can make individual drawings from this in the body plan. It's called the framing plan, like this. Say this is frame 10. This is the shape, and from this curvature, that is, this goes to the hull shop, and the frames are bent to this curvature. After this information is supplied to the mold loft, and he makes the full scale drawing from this frame plans. That is how the ship is fabricated, and here again one if you want to make an accurate structural drawing, you should make it on the what is called the molded lines. Now molded lines are very important for arrangement of floors. Then you have frames, deck beams, deck girders. So lines plan actually gives you this molded lines information, and I have already talked about this molded section. You will find say let us take the section of a ship. Drawing actually symmetry doesn't form it. So here this is your center plane or center line which you may draw, and whenever you are drawing, first you draw this vertical center line, so that gives the reference line, and the other reference line is your molded baseline. MBL is called the molded baseline. Now all your dimensions here, actually the shell thickness will lie outside this molded line. So this is your shell thickness. And just taken a very simple view. Next, your deck, I have shown certain camber of the deck. That is, the deck is a curvature. So this is your deck line. So molded breadth is the maximum breadth at midship. Maximum breadth at midship, which is from inside of the shell plate. So this is your molded breadth. Next, if you want to make the molded depth, again it should be below the deck plating. So this is your molded depth. So that means the shell plating thickness is excluded from the measurement of the molded dimensions, it is not included. Now here there is another point which one should remember, is called the camber of the deck. I think you must have come across this term. That is the difference in the height at the center line and height of the deck at center line, deck at center, and the deck at side. So that is called the camber. Definition. Yeah. This is so deck at side is this line. So this line is your deck at side. And this is your deck at center. So this camber actually, it was given in ships, that is in olden ships, such that the water runs off the deck remains dry. Normally in roads also you will find camber, so that is given especially for draining of the deck. Otherwise, if the crew does not want to work in a wet deck, ship's deck has to be maintained dry for the safety of the crew. He should not slip on the deck, and by slipping he should not fall overboard. So normally you will find when you are, so that is why the camber is given. There is another nomenclature which you will come across, that is called shear. In the lines drawing, you will see that the deck also is having a curvature. So camber is curvature, this is called athwart-ship curvature. Athwart-ship curvature of the deck. Now you can also give some longitudinal curvature to the deck. Because here you will find that the deck is having practically no curvature at the aft end, but the slope is given at the forward end. So this is called shear. Shear, that means the deck is having certain kind of shear. shear is the vertical distance measured from a horizontal line passing through the midship at, say, at every stations, measured from this line to the deck at side. That is this distance is called shear. So this is shear at the forward perpendicular. Now what is the shear at midship? Shear at midship is 0. But if I extend this deck like this, you can see that even at the after perpendicular I am having a shear. In this station also there will be shear. So in olden ships or old ships you will find the deck is having shear both at the forward end and also the aft end. But nowadays actually they have done away with this shear. This shear, there is a requirement, there is a reason behind giving a shear to the deck. One is to increase the internal volume, that is the first reason, and second reason is that when the ship sails, there is a particular elevation from the deck at the forward end is given. So this is called bow height. According to your load line rules, this bow height or what is called bow height is given in load line rules. Now this bow height is given there for reasons, that means your green seas should not come and on board the ship, on the deck. The waves should not come and crash on the deck. That is why the slope of the deck at the forward region is given. That is one reason. The other reason I told you is to increase the volume. That is, if you increase the volume, you will get certain amount of reserve buoyancy and this part. So normally when you study the load line rules, previous class I have talked about how these load line rules are given. That is, load line rules are important for freeboard calculations. And if you have this kind of shear of the deck, you are allowed to load the vessel to a little bit larger draft than specified by your load line mark. So there are certain calculations, of course, which if I cannot explain in this class, it will take too much of time. You look into the load line rules, especially the 1966 load line rules. I think for a few years I am without touch with these load line rules. Nowadays the new rules have come up from year 2000. Normally if you look at these load line rules, the ships are classed, say class A, class B like this. I suppose you have come across these terms. Say class A pertains to oil tankers. Oil tankers have pretty small freeboard. This class A freeboard is given to tankers and ships carrying liquid cargo because they are entitled to a minimum freeboard by the nature of their openings on the deck. Tankers you will find very little openings on the deck, isn't it? Because they have to take in only the oil pipe or the cargo delivery pipelines. It doesn't require much hatch opening. Whereas in class B ships, you have the normal tankers come under this category, class A ship. Class B ships, you have cargo ships, general cargo, bulk carrier, etc., which by the nature of the loading of the cargo, you require a larger hatch opening. So, if you have a larger hatch opening, there is always the danger of water coming and flooding the holds, because you are having a large opening. So, normally you will find cargo ships having a larger freeboard than your oil tankers. For safety reasons it is given, and these are specified in these load line rules. So, whenever you want to uh, measure the freeboard, you have to refer to the load line rules pertaining to class A or class B type freeboard. It is specified. So, this will be type A freeboard, and the other type of freeboard will be called type B freeboard, and here you will find the length of the ship. So, for the same length of the vessel, you will find type A freeboard to be less than type B freeboard. So, again you have other freeboard, of course, we will call B60 freeboard, then you have B100 freeboard, etc. B100 will be the same as the tankers. That means the cargo ship is designed with openings or extent of openings in such a way that it is considered to be as safe as a tanker. So, it is given some concession, and we say that it is a B100 type freeboard ship, cargo ship. Similarly, if you comply with 60% with lesser amount of the requirement of tanker freeboard, then you may be given B60 freeboard. Why? The reason is the owner of the ship will always want the ship to sail at a deeper draft. He wants to carry more cargo in order to increase his earnings. So, if you tell him that I will give you a large amount of freeboard for safety reasons, he will be unhappy, isn't it? So, normally this freeboard marking has come because in the past there was a tendency for the ship owners to carry a large amount of cargo, especially cattle on the deck of the ship. So, that increased the risk of the vessel to sinking, and there was overloading of the vessel. So, that means nowadays the regulatory authorities have put a restriction by imposing this load line mark. So, anyway, so this load line mark is with reference to your freeboard, and freeboard for the time being you simply remember that there are two types of freeboard called type A and type B freeboard, or class A or class B ship. Normally they are called class A and class B ships, type A and type B freeboard. A is with reference to your ships carrying liquid cargo, that is tankers, and B is reference to your cargo ships. So, your molded depth will come to this line. So, from the top of keel to the horizontal line passing through the lowest point of the deckhead side. So, this was shear, and shear also has to be indicated in the lines drawing. So, that means the deckhead side that you have drawn in the profile will no more be a straight line, but it will have a longitudinal curvature. Of course, the camber you cannot show in the curve, but the shear, since you are drawing the deckhead side, should be clearly indicated in the profile view. In the profile view you will have this shear curve. So, this is we incorporated in the lines drawing. In camber, here I have drawn what is a straight line camber. You can see that there is a flat region at the center line, and then there is a straight portion coming down from the center line. So, this is a straight line camber. Normally you will find in olden ships are given a sort of a curvature or a curved camber like this. So, the maximum amount of curvature will be at the center line of the ship, and this amount I think is there is a certain ratio. B by 50 is the normal amount of camber that is given at the center line. B50, I think the figure I am talking about is right. Here it is not mentioned. Normally I think 1/50th of the breadth of the ship, there is a vertical camber that is given. Yeah. So this is one point, and here also the other point, that the deck, uh, this you will find rarely in cargo ships. Say this, for simplicity I have just drawn the deck flat, but here you can see that the side shell is having a curvature somewhat inside at the deck. So that is called a tumble home. So if you just draw the molded line from the shell, this is called a tumble home. And sometimes this tumble home is given with a definite purpose. That means the ship, normally you will find, especially in tugs, you just look at the stern portion of a tug, you will find this tumble home quite pronounced. Say this is your stern portion, and here in the tug you will find the deck line to be like this. Why? Because the tow rope that is coming or towing the vessel is likely to go down below the deck like this. Now, if you have a very sharp deck edge like this, so it might uh, tear off the rope. So these tumble homes are normally given for drawing in your, say, your mooring lines or your ropes, etc. They are called tumble home. And the opposite of this tumble home is called a flare. The deck, the shell plating will not be having a curvature towards the ship's center line, but it will be having curvature outside. That means the deck is having a flare like this. And this, sorry, it will be something like this. Now, normally you will find this kind of shape to be there in aircraft carriers. So that means in aircraft carriers, you are actually increasing the deck area, isn't it, by giving a flare. So this is called deck flare. So purposely I am increasing the breadth of the ship by giving it a flare. Of course, if you increase the breadth, normally hydrostatics, you will find you increase the stability to some extent. By increasing the moment of inertia of the deck. I think you must have come across this term BM. BM is the moment of inertia of the deck divided by the underwater volume. However, sometimes this is done. If you have larger amount of breadth, that you will have greater stability of the ship rather than a ship having smaller breadth. That is, your slender ships are not very stable, they will tend to capsize. But you have a larger beam, then of course the BM will be more because of larger moment of inertia, give you more stability. So this deck, if it is curved inwards, it is called a tumble home, and it is curved outwards, it is having a flare. Now, other points on the body plan that you should remember is, normally you will find there is a rise of floor. Of course, this is somewhat enlarged. Now, you draw the molded baseline and say this is the molded line of breadth, that is the maximum line, and you draw a tangent at the bottom. That means the bottom shell is not lying flat on the baseline, but it is having a slope, and this amount of slope is called dead rise, or rise of floor. In naval architecture terms, floor does not mean your flat floor that you can normally see in the room, but those are vertical members, vertical structural members. They are called floors. These floors are having stiffeners which are called brackets, and inside you may have lightning holes through which your pipes will pass. You may have a faceplate also, or on top the inner bottom will be there. But this structural arrangement you will cover in a better drawing. Anyway, for our lines drawing, you simply remember that this slope of the bottom shell at the midship, that is called a dead rise or rise of floor. Now, when the lines drawing is made, actually this rise of floor is taken into account for docking the vessel. So, your keel blocks will come here. So, this angle of dead rise should take account the ease of docking the vessel. The vessel should come and dock evenly on the keel. So, where the normally in tankers and cargo ships having a fuller form, they do not have any dead rise. It is full flat. This you will find normally in smaller ships like tugs, trawlers, etc. They are having, why the reason is because their midship section area is not full. They are having a much more reduced midship section area to give less resistance to waves, having a finer form. For fine form ships, you do not have the fuller sections, you have much more sharper sections, and that is why this dead rise is coming. For tankers and cargo ships, you will find this to be absolutely flat. There is absolutely no dead rise angle. Flat bottom vessels are easier to dock, but flat bottom vessels are very difficult if you want to tow the vessel from what is called from a grounded state, because there will be increased friction in between the ground and the bottom shell. So, normally you will find tugs and trawlers, they can, sometimes they are beached, so you have to quickly take out the vessel to the sea, and they have this kind of, they have a large dead rise angle. You just see the cross section of trawlers. This is a large dead rise is given for that particular reason. And here you will find in tankers and cargo ships, you will find the keel to be flat keel with a certain box, or a box type of keel. But in the trawlers, you will find there is a skeg coming out of the hull like this. So, this is called a skeg. And of course, the keel blocks you can rest it like this. So, different lines planned for trawler and completely different lines planned for your tankers and cargo ships. So, all this actually the lines plan will tell you the function of the vessel itself. Now, similarly in tugs and trawlers, normally the lines that I have previously drawn, you will find that you would have found that the keel, the bottommost part of the ship, that is called the keel, to be the resting on the same baseline, that is without having a inclination, but keel also does have inclination. Sorry, this is an enlarged view. a trawler will, in all practical purposes, all these small trawlers, they have a keel which is inclined to the baseline, and the amount of inclination is called rake of keel. Sorry, this will cross somewhere here at midship. So this is your molded baseline, and this is your keel line. Now this rake of keel, I think it has not been mentioned here. I think this is the, at AP, if you produce this to the AP, this amount, this distance is called the rake. I'm just checking, I think it may be wrong, but here it is, but this is quite important actually. I don't know why it has not been mentioned here. There is another book. I mean, some of the things have been lifted from this book, Ship Design and Construction. This gives you further definitions. This is by a gentleman by Taggart. Gentleman called Taggart, same Sname Publications. So some definitions have been taken from here. It is not mentioned probably here. You refer to this book also, Ship Design and Construction by Taggart, and the same book was actually previously edited by Arcangelo. It gives you in detail how the ship is constructed, etc., with all these definitions. So this rake of keel again is given especially in tugs and trawlers. Why? The reason, there are a number of reasons. One reason is to for ease of docking, I told you, and taking out the vessel if it is grounded on the beach. Another reason is, you can see that this portion of the vessel that means this portion is that is the skeg. This is called a skeg. Now this skeg gives directional stability to the ship. Actually, in small vessels, they may not be directionally stable. It is very difficult to keep them on course unless at the after region at the propeller end. So, this is your propeller and you have your rudder here. You gave this keg, this is given for directional stability and ease of taking out the vessel from the beach if it has grounded. So, these are the two important reasons. Another important reason is you are increasing the keg by giving a keg, you are increasing the draft at the after perpendicular. So, here you can see draft at the after perpendicular is fairly larger than draft at the forward perpendicular. So, these are some of the points one has to remember when one makes the lines of a fishing trawler or for a tug. So, this gives directional stability, it increases draft at the after perpendicular. Why this is necessary? In order to house a larger diameter propeller. Tugs and trawlers, they are highly powered vessels. That means the bhp of the engine is quite larger than your ships, cargo ships or tankers. The amount of power you require per ton in case of a tug or a trawler is much more. For that, since the propeller has to deliver a higher horsepower, so normally the diameter is also increased in order to accommodate a larger blade area ratio. Propeller, if you look at the propeller of a tug, will have a larger amount of blade area ratio with the maximum amount of diameter. So, if you want to immerse the large diameter propeller, obviously a small draft will not be sufficient for propeller immersion. When the propeller is not fully immersed, it will not give the maximum amount of thrust. The propeller will cavitate and will lose thrust. So, for sufficient propeller immersion and to house a larger diameter propeller, normally this rake of keel is given. Forward end, of course, you do not require this. So, but the ship is floating at horizontally. I mean, there is no inclination of the bulkheads or the inside of the ship. They are vertical, but only the keel is having this kind of a slant or a slope. So, this is the rake of keel. And in lines drawing, there is skeg. I have already told you, skeg, riser floor, the camber, tumble home, and any other items that has missed. And these you must have noted, that is, lines should show when you are drawing the main deck or the profile, you also have to show the extensions of the hull beyond the main deck. Right. So, you have drawn the main deck line, fine, but the hull of the ship, the hull actually is a watertight envelope. Now, this hull actually extends, you look at the forward region, the hull extends beyond the main deck line at the forward region. So, here again this is called a forecastle or forward, sometimes this is written as forecastle, FCL, and near the stern portion this is called a poop. and of course you have a wheelhouse, and then you have the bridge deck. So this forecastle and poop, and in older ships you have also the hull is also protects some, at the midship region also there is an extension of the hull. Normally here nowadays we don't have this. Now this forecastle is an extension of the side shell, forecastle and poop, and they also have to be indicated both in the on the half breadth plan. All the three sections you have to show. Say you draw the main deck line, and here you mark the boundaries of the poop, and the breadth of the forecastle also has to be clearly marked in the half breadth plan. And similarly, you have to show this also on the body plan. Say this is a main deck line is up to here, then extension will show the forecastle leg like this. And in this, actually my drawing is not proper. Yeah, something like that. You will come here and then here it will merge with the main deck. So this is your forecastle deck. This is your main deck. So all decks are to be clearly shown in the profile, and also in the body plan, and also in the half breadth plan. Now these forecastle and poop, the why they are given, you can see that they are extension of the hull. Now one reason is you increase the bow height at the forward region. Here if you drop a perpendicular, the height from the at the forward perpendicular to the load water line is increased if you have a forecastle. And forecastle also you can carry some amount of cargo in this. It is an enclosed volume, so you can carry cargo in the forecastle and also in the poop deck. So that is why, or you can use it for storage of ropes, lanterns. All these are located at the forecastle. They are not located, and other deck machinery, that is deck items will be stored. Of course, your windlass will come on top of the forecastle, and here you may have a chain locker that of course will be there, but still other items that are used on the deck, they are normally stored in the forecastle. So forecastle actually, forecastle and poop, which are nothing but extension of the side shell, they increase your buoyancy and stability by increasing the gross enveloped volume. This watertight envelope is the volume which contributes to your buoyancy and stability. So that is increased sorry, if you have a forecastle and a poop deck. So all these items have to be clearly indicated in the three plans, that is your half breadth plan, your profile, and the body plan. So this next class I will talk about your diagonals, since I don't have time. Diagonals and your diagonals and offset table. Actually, this offset table, that is the dimensions that are given in this offset table, from this only you can create the lines drawing. You have to create the lines drawing from a set of offsets, and offsets are nothing but the half breadths set out on the water line or water plane at specified stations along the ship. So those are called offsets. So once you have got the offset table, or once you are supplied with the offset table, then only you can draw the ship lines. So this brings us to the end of this lecture. So next class I will continue with the offset table.